Okay guys, 10.2 examples of arc measure. Number 1, find the measure of each arc of circle P, where RT is a diameter. Identify each arc as a major arc, a minor arc, or a semicircle. Letter A, RS. Okay, so what they're saying, here's R, we're going to S. And the reason we go the short way is because it only gives 2 letters. If it wanted us to go around the long way, it would have given us 3. So, do you guys see the corresponding central angle that RS kind of aligns with? Well, if the central angle is 110 degrees, guess what? RS also 110 degrees. Then, because that is less than 180, we can call it a minor arc. Next one, RTS. R T S. Okay, so now we got to figure out this guy. So the first thing I'm looking at is, do you remember this information? RT is a diameter. Well, if we've got a diameter, we've got half of the circle. And half of the circle, I hope we know, is 180 degrees. Another way to justify that is because it's a straight angle. So remember, a straight angle is also 180 degrees. Then I've got 180 here. I don't know what this guy is. Well, if there's 180 over there, there's 180 over here. So for this guy, we could do 180 minus 110, which is going to get us 70. So I know that guy's 70. So if I want to do RTS, I'm going to take 180 plus 70. So let me see. 180 plus 70 is 250. And I just realized that I did that the really, really, really hard way. Was anybody thinking, wow, that could have been a lot easier? We could have just taken 360, which is the whole circle, and subtracted off the 110. That would have been a lot easier. Anyways, 250 degrees, more than 180, that's a major arc. RST. R S T. Half the circle, 180 degrees. Which means that's a semicircle. Let's try that again. Find the measure of each arc. Identify each arc as major, minor, or semicircle. GE. So first of all, GE. So if I want GE, here's my corresponding central angle. I've got an 80 degrees and a 40 degrees, so I'm going to take 80 plus 40, which is 120. So that's the measure. And then because it's less than 180, I'm also given 2 letters. I know that it's minor. GEF. G E F. Well, I already know that out here is 120, up to there. And then I know that adding on, I've got another 110. So I'm going to take my 120, I'm going to add on my 110, which gets me 230, and then that is more than 180, so major. GF. Okay, well, GF. And keep in mind, we go the black way because it's only 2 letters, so you go right from G to F. You don't swing the whole way around and go GEF again. Okay, so now I'm looking, I've got this red part out here. Well, I know that that was 230. Well, my black part kind of makes the rest of the circle. So this time I'm going to take the easier route, and I'm going to say, okay, well, the whole circle is 360 minus that red part, which is 230. So 360 minus 230 leaves me with 130. So I know this part has to be 130. And then because it's less than 180, minor. Okay, using all of that information, find the value of x. Then find the measure of each labeled arc. Okay, and specifically in my picture, it has this red piece, so I think it wants us to find that red piece too. Okay, taking a look at what I got. First thing I'm looking at is I'm looking at this right here. To me, pretty sure that's a diameter, which means this whole side of the circle has to be 180 degrees. So I'm going to take my 2x minus 30. I'm going to add on my x, and I know all of it on that half of the semicircle, or that semicircle, has to be 180. Combine like terms. 3x minus 30 equals 180. Add your 30, which 3x equals 210. Divide by 3. X equals 70. And then we also have to find the measure of each labeled arc. So AC is labeled as just x. So I know AC, we can put an M there. So the measure of AC is 70 degrees. And then we can do 2 times 70 minus 30. So 140 minus 30 is 110. So the measure of BC is 110. And then when you add those together, 110 and 70, you better get 180, which you do. Letter B. Take a look at what we got. We got to find the value of x, and then we have to find the measure of each labeled arc. Okay, so on this one, my first thought is they kind of gave us the whole circle. And I know that the whole circle adds to 360. So I'm going to take 4x plus 6x plus 7x plus 7x, which is the whole circle, adds to 360 degrees. So combine like terms. 4 plus 6 plus 7 plus 7, 24x equals 360 degrees. 360 divided by 24 gets me 15. So I know x is 15. If we go back, 7 times 15 is 105. 105. 4 times 15 is 60. 6 times 15 is 90. And then specifically, because I've got this little red part here, I'm going to say the measure of RST, put my little arc, equals, well, I've got a 90 plus 105. 90 plus 105 is 195 degrees. And just in case, I was looking right here. RST. So I just added my 90 and my 105. Okay, number 4. Tell whether the red, and I put that in quotations because if you printed this off, you're probably not seeing red. So tell whether the red arcs are congruent. Explain why or why not. Keep in mind, congruent. Exactly the same. Okay, congruent. Same size, same measure, same everything. Similar is same shape but different size. Okay, so the first thing I'm looking at is I'm looking at my central angles. 145 degrees. 145 degrees. Well, that's the same. So far so good. Then do you notice that my radii are the same? So think about this for a minute. If I have the same central angle and the circles are the same exact size, then would these arcs be the same exact length? And the answer to that is yes. So yes, congruent. And it says explain. So I'm going to say same arc measure. Okay, they're both 145 degrees. Same size circle because it marked the radii as the same. Letter B. Take a look at that. Are the red arcs congruent? So once again, I'm looking at my central angle, 120, 120. So they're both 120 degrees. So this arc is 120 degrees. This arc is 120 degrees. But this one has a radius of 5, and this one has a radius of 4. So are the circles the same size? No, that one's smaller. So even though it's 120 degrees, they're not the same size arc because one circle is smaller than the other, which means the circumference, which is the distance around the outside, is not the same. This guy over here is going to have a smaller circumference and therefore a smaller section right there. So no, not congruent. Circles, not same size. Okay, now that sums up 10.2, and at the end of this lesson, not only do you have to do your big ideas homework, but there is also a posted extra practice 10.1 and 10.2 worksheet. Make sure you work that out and check your answers. I have provided them. I guarantee that they're going to be very, very helpful on your quiz that you have to take next. So the next thing coming up is a 10.1 and a 10.2 quiz. Make sure you get that taken so that you can move on to the next section.